Okay, guys, this is your foldable. Okay, looks like this on both sides. I went ahead and tri-folded it because you're going to end up gluing it in there. Okay, once you're done, if you have time, if is the word that you may or may not have, you can color it when you're done. Okay, so let's go ahead and open it up and let's fill it in together. And it says, why do we have seasons? It says the earth tilts on its axis at, I'm going to say about 23 degrees. If you want to write 23.5, that's fine as well. Okay, it's up to you. So again, it's tilted right here, as you can see. So right here, we're going to continue. It says the amount of sunlight depends on the blank of the earth. So the amount of sunlight depends on the tilt of the earth at a given time of the year. So depending on your blank, it says how close or far away from the equator. So if you're talking about the equator is the central part, okay? It's that imaginary line, horizontal line through our earth, okay? You're not going to ever ride up on the equator and see a black line. It's just imaginary. It's going to be 0, okay? And so depending on your latitude, which if you haven't already, Miss Brown's latitude is going up. So there's little bitty lines that go horizontally on a globe or a map. Will make a difference to the seasonal difference that you will have. The further north or south of the equator, the blank, so further north or south of the equator, the more drastic the seasons. Okay, obviously because you're going to have the direct hit here, but the farther north you go, it's going to be vastly different, the North Pole, than in the equator, no matter the season. No matter summer, winter, fall, spring, going to be completely different when you're talking about the equator. Okay, versus in the equator, right on the equator, let's see, less drastic seasonal change. Because again, that's why everyone likes the tropics, because it stays warm all year long. Okay? So again, so it says the position of the earth at different times of the year. Okay? So you've got right here these equinox. It says spring and equinox and fall equinox. Equinox is a simple way of saying equal day and night. We know that right now we're in the winter. We don't have the equal day and night. Okay? That is because the way we're tilted during our season. But equal day and night. So it's kind of like 12 hour and 12 hour. We're not getting 12 hour and 12 hour, geez, because it's getting dark at like 5:30, 6 o'clock. Okay? And so this is what it means by equinox. Okay? And then again, right here you got your solstice, which is your different times. Like the summer, it's obviously going to be longer. It's going to be daylight longer versus in the winter right now. The night is going to be longer as far as your hours. Okay? All right, so fun fact. Fun fact, the sun is the closest the earth is going to be in January, which is crazy. But again, we feel that differently than the southern part because we are tilted away from the sun in January because that is our winter. Even though technically the sun is closest to us, we're farther away just simply because our tilt away from the sun. Okay, then the opposite here is the fun fact. The seasons are blank of each other in the northern hemisphere, just like you saw in the movies. If I'm here in America and then I've got my buddy in Australia, we're experiencing opposite seasons. Okay, so that's why the equator is so important. Okay, it differentiates between your northern and your southern hemispheres, which experience your seasons quite differently. So again, we're having that's why again, in the southern hemisphere, because they're tilted toward, they're going to be receiving more sunlight because they are directly, so that is their winter. That's why down here it's going to be summer for them because they are closer to the sun in January. And that's why they're opposite than we are in January. Okay? All right. So the big thing I want you to take away is, again, the tilt and the position where we are in reference to the sun. Okay? So again, right here is your equinox and your solstice, okay? Talking about is when the sun is shining directly above the equator. This is where you get your equal day and night / night. Okay? And then again, your solstice obviously is not directly on to the equator. So it occurs when the sun is furthest north or south of the equator. Again, this is going to be your, going back, and this is going to be your summer and your winter solstice. This is going to be during the winter and the summer. Again, being able to feel the difference with the amount of daylight versus your hours. So think about your hours. So your equinox and solstice are based on your hours of the day. Okay, so go ahead and I want you to glue this into your next empty page of your math binder, excuse me, math and science binder in your science section. Please go ahead, if you want to, go ahead. And if you want to take a few minutes and color this, that's absolutely fine. When you're done, read your hyperdoc to see what your next step is.